All right. Can you guys hear me and can you see my screen? Um, Anyone?
Yes, we can.
Okay, sounds good. Let's start. So I'm Ashwin Devanga. So I work in the field of machine learning, in particular reinforcement learning. I am currently working under Professor Degani. I am a master student, but I'm working I'm doing a few projects under Professor Degani. Um, I This is my email ID here. If by chance you have any questions which I could not answer in today's talk, uh, I will reach out to you, or you can reach out to me here on this email ID. All right. So today I do want, before we start on the core programming principles, I do want to take some time to explain the history of Python, as in why do we use Python and not anything else? Why is R not as popular as Python? And what are the differences between Python 2 and Python 3? Why was there a major shift in around 2018? People started moving to Python 3 instead of Python 2. Why did this happen? And things like that. So the major reason was Python 2 was dead. They ended support in 2018, and on January 1st, 2020, they decided that it is declared end of life. So Python 2 is not used anymore, but Python 2 is still important for some particular packages. So a major one being VirtualBox. VirtualBox still uses Python 2 packages. I believe this has been patched in version 6.18 of VirtualBox, but so far I have not tried out version 6.18 yet. So up to 6.16, it was still using Python 2. So what this means is that legacy software is still going to use Python 2, but it is not being supported. The major difference between Python 2 and Python 3 was the support for Unicode was extended. Do anyone have doubts about what Unicode and ASCII is? Please, I don't mind you guys speaking up. It is a pretty small section, so do speak up. Do you guys know what ASCII and Unicode is?
Hey, I know what ASCII is, but I don't know what Unicode is.
Okay, so Unicode is, in extremely loose terms, is similar to ASCII with a large support for different other different characters. So German characters, for example, or Hindi characters, for example, were not supported by ASCII. ASCII was supporting singular English characters. I believe 217 characters was being supported, which includes new line and all those characters as well, breakpoints. But Unicode has an extended range of characters, and you can add new characters as well. Uh, this was obviously important. Other than this, one of the major changes which was seen by developers was the change in the print statement syntax and in integer division. So when you take a look at, if you divide 1 by 2, you expect an output of 0.5, but Python 2 used to give an output of 0. So the output of an integer by an integer was always an integer, which was flowed down. So even if the output was supposed to be 0.9, you used to get a 0. It was not rounded, but it was flowed. People looked at this as a feature rather than a bug, but we all know that it is not accurate, and it was supposed to be changed. The print statement is another thing. So in general, let me just open up a new Python file here. It used to look something like this. So in Python 2, you could do hello like this, and it used to run. But Python 2 also allowed you to put it in parentheses as well. Uh, but I'm sorry. But it was not a function per se. It was something of an inbuilt method. It was Python 3 stresses a bit more on the OOPS functionality, which is object oriented programming functionality. So you can easily create objects, destroy objects better than in Python 2, which is a great thing for the data scientists or people working in with large amounts of data, because you do call a lot of functions and it's preferable to use them as objects. So moving on, Python versus other programming languages, Java and C. So you guys would have heard the term low level language, intermediate level language, or middle level language, and then a high level language. And if you have studied Java or C in your undergrad or previously, you, I'm sorry, does someone have a question? Okay, anyway, let's continue. You would have heard that Python, Java, and C is a high-level language, but technically speaking, technically yes, it is a high-level language, but it is not as high as Python. So when the terminology of low-level language, intermediate level language, and high-level language was coined at a time when higher-level languages did not exist. So at that time, Java or C, not Java, Java came in 1991, but C was considered as a high level language, but it has the innate ability to communicate with hardware much better than any other language we know. Right now, there is a glorified version of C coming up as called Rust. You might have heard of it, which is essentially C without the security issues such as buffer overflows and things like that. But it is still C, and so C can be considered as an intermediate language rather than a high-level language. Java would be a high-level language because it runs on a virtual machine. It has some. It cannot work with hardware. The reason Java is hated by a majority of the coding community is because you can't access serial hardware. You can't use Bluetooth using Java-based applications. I mean, you can, but it is extremely difficult. But the advantage of Java is that since it runs on a virtual machine, it can be compiled on any other environment and can be ported. The bytecodes can be ported to any other environment other than the compiler environment, and it will still run the same. So interpreters and compilers. So this is again at the base of the Python programming language. Python is a purely interpreted language. However, C is a purely compiled language. Java, on the other hand, is both compiled and then interpreted. So C uses compilers such as GCC, TCC. GCC stands for GNU Compiler Collection, and TCC is Tiny C Compiler. C-Lang was recently developed after GCC went on to change the licensing from, I believe it is GPL version 2 to version 3, and C-Lang, many people were not happy with it, so C-Lang was born. But the advantage of a compiled language is that it runs extremely fast. It is already machine code which has to be directly executed by the computer. It is directly fed into the processor and the processor spits output. Interpreters, on the other hand, have to run through the code line by line during the time of execution and have to, it is much slower. That's the point. There is no machine file generated as such. But the advantage of interpreted languages is you can see runtime errors beforehand, before compilation, so you can make changes as required. C, for example, if you feed in, you get you get errors such as, when you, for example, if you buffer overflow an array in C, you get errors. I don't remember the exact error code though. Anyway, Java is a compiled and interpreted language. This makes it much faster than Python, but slower than C. Java requires the second interpreter because it runs on a virtual machine. The compiler for Java is Javac, JAVAC, which is Java compiler, and the virtual machine, to run it on the virtual machine, you use Java as the interpreter. But coming to Python, in many people don't know this, but Python has multiple interpreters. We usually, when we refer to Python, we generally talk of C Python, which is the default with most environments, and people generally don't want to stray out of it. It is the jack of all trades in a way. But there are other interpreters for Python. Major one which data scientists do use from time to time is PyPy or PyPy. It is much, much faster than C Python, or in some places, I believe it is called as Python as well. The problem is that all other interpreters are forked from C Python, which is built by the Python development community, the community of who work on Python. So it always works on a subset of the functionality of C Python and not all function, and it doesn't have everything else, everything included. So in general, it is better off if we stick to C Python, which is the default interpreter. Any questions so far before we move into visualization? Anyone? All right, let's move into visualization then. So the theory of visualization is, you see, anyone can plot graphs. Programming, you can plot graphs, but to get good graphs, which actually make sense, which are required graphs, which actually portray the message which you're trying to show, that requires you to think about how the data needs to be presented, which type of graphs should be used, what kind of data needs to be plotted, and all these. So there are 3 steps of to plot a good graph, and it is called the stages of understanding. So you put yourself in the shoes of the viewers who are going to be viewing your visualization, and then check how are they going to interpret or understand the graph. So in the first step, you would ask yourself these 4 questions, which is the first stage is perceiving, which is, where are the largest, middle-sized, and smallest values? What this means is that you want to, when you look at the graph, can you identify the different values? Can you actually see the largest value, the smallest value? Can you see where the mean is, the median is? Things like this. And the next question is, what proportion of the total does the value hold? This applies to, for example, if you take a look at histograms, you can see you would be able to see the frequency of a value occurring. Or so if you take a look at a value, you want to see whether it is the data points are densely populated around a region or not. Things like these can be seen using the proportion of using this question. And then we move on to how do these values compare in ranking terms? Can you get some output from it, such as, okay, so this is the best option, this is the second best option, this is the third best option, things like that. Can you make can you infer these can get these ideas from looking at the visualization? And finally, to which other values does this have a connecting relationship? So you would have multiple plots, right? So are these plots related? Can you do they tell a story? Is the question. If you can answer these questions in a positive way, you're probably on the right track. You're making good visualization. Similarly, for the second step, you have these questions. I will not be going into all the questions because I have provided you the link for with this document and you can read through it. It it basically is, if you can answer all these questions, there are a total of 12 questions here, and if you can answer these 12 questions in a positive way, your visualization is a good one. All right. So let's start with the interesting part, which is obviously the programming. So we will be talking about Numpy, Pandas, and Matplotlib. Numpy is the mathematical package, Pandas is the data management package, and Matplotlib is the visualization package, which we will be using. I will be showing a few other packages for visualization as well. But I will not be explaining as to how the syntax and all of that behind those packages. These packages are the ones which I will be concentrating on. So Numpy is, as I said, the mathematical package. You can do vector calculations, matrix calculations. You can do all kinds of algebraic calculations using this package. You can generate distributions as well. It has the random package of Python inbuilt into Numpy as they have forked it into Numpy as well. So Numpy can generate random values, can generate distributions and things like that. So here, first I want to talk about the differences in data structures between the native Python interpreter and Numpy. So arrays in Python are called as lists, and in Numpy it is called Numpy arrays. The difference is that calculations on Numpy arrays is much more intuitive than it is on Python lists. So for example, if you multiply a two-dimensional list with a single constant, it does not do what you expect it to do. Numpy, on the other hand, will make sure that all the elements in or in the matrix, in the 2 by n matrix which you have, is going to be multiplied with the constant. So let me just showcase this here. So B1 here is a Numpy array. As you can see, visually as well, you can see that it is very different from the list. It is not separated by commas or anything. However, it does work similar to the Python list. Of course, you can't do append. For example, here, if you want to add an element to the end of an array, in general, you do the list dot append and the value which you want to append into the list. Here you do numpy.append and then you mention the array and the value. You see that the append function for lists is not, it returns a none value or a nan. It doesn't have a return value per se, but numpy.append has to be assigned to the value again. It does not append it to B1 directly. Reshaping is a useful tool when you want to generate random data sets and things like this. So if you have a single dimensional array, so here we are looking at B2. So if you have an array with 10 elements starting from 1 ending at 10, and you can reshape it to be multi-dimensional arrays or matrices per se using the reshape tool. Taking a look here, as you can see, it is reshaping it into rows and then columns. If B1 was the without the 10, so I could shape it into a 3 by 3 matrix, a square matrix here. Now, matrix multiplication is generally called as dot products. These are very simple using Numpy. Using lists, you'll have to write your own function, but Numpy has a built-in function called dot, which multiplies your matrix, the two matrices. Obviously, it has to be, you have to make sure that the dimensions are right, so that it is possible to multiply the two matrices. Otherwise, it does spit out an error. Uh, Here, as you can see, the shape of B3 and B4 was 5, 2, and 2, 5, which is from this. So you get a 5 by 5 matrix as expected. If you had multiplied B4 and B3, you would obviously return a 2 by 2 matrix. It is essentially the dot product of the two-way vector. The vectors, if you consider each row as a vector, it is the dot product of the two vectors. Moving on, here we have two new functions which I want to explain here. Numpy.arrange, it creates an ordered list from the minimum value, minimum integer to the maximum integer. The maximum integer is obviously not included, similar to the range function in built into Python. So np.arrange 1 to 4 gave an output of 1, 2, and 3. It is going to return a numpy array. It is not going to return a Python list. So I just explained the dot product again is as it is here. So it is 1, 2, 3, 1 into 11 plus 2 into 12 plus 3 into 13, which is 74. Cross products, as you guys know, can be done on 2 or 3 dimensional arrays only. So that is the reason I have three valued arrays here. 1, 2, 3. It has just 3 elements, and the cross product can be found by using np.cross. Moving on, here we have searching through an numpy array. Numpy has a built-in function called where, which helps you search for elements inside the list. It always returns an array. So the location, the indexes of where the value 4 is located in this array is returned. So 4 is here, which is 0, 1, 2, 3. So 3 is here, then 5 and 6. The indexes are returned. The return type is a tuple. Do you guys know what a tuple is? Do you know the data structure tuple? Anyone?
Could you explain it really quickly? That would be great.
Yeah, sure. So tuples are ordered lists in a way. So if you want to explain, if you want to map coordinates, for example, you have X and Y, and it has to be met in that order. Though lists can do this, can work in this case, sometimes you do need a tuple. It is enclosed, instead of in square brackets, it is enclosed in parentheses, and it works very similar to a list, for the most part. It does not have some of the functions which the list has. I believe append does not exist for a tuple, though don't quote me on that. Here in this case, it returns an array in the first part of the tuple. The second part contains the D type. This, however, cannot be accessed if we, for example, if we do X of 1, it is going to give you an error because tuple index is out of range. It doesn't identify this as a part of the tuple, but it basically tells you what the data type of each of these values are. And in this case, it is an integer 64. The point which I want to make, which I want you guys to note here, is that even if there is a single appearance of the element, it is still going to be in an array. So you need, if you want to extract the array, the element, you need to make sure that you use something like this to get the element out, or you can cycle through a loop with the length of the array. Similarly here, the condition which is put here need not be just an equal to. You can put in any kind of mathematical function which results in a Boolean value. So if you want to find where all the even elements are, you can just do this and you get an output, which, so 1, 3, 5, and 7 are going to have are even, and you get an array as so. Before we move on, any questions on any of the functions? Am I going too fast? Anything? Please let me know. Anyone? Okay, then I guess I'll continue. So the sometimes you want to convert a Python list into a NumPy array, or you want to convert a NumPy array into a Python list. You would do np.array to convert the Python list into a NumPy array. This part is optional. The reason I have put it in here is to show you that it converts it into a float value, though in the original array, it was in the original list, it was an integer. And if you convert this back into a list, now you have a Python list with float values. This is a quick way to convert a Python list data types, because Python lists by itself don't have a function to convert the data types inside the list, because Python lists in general can hold different values, unlike a NumPy array, which can hold just a single type of value. So a Python list can hold a string and then an integer and a float and everything in a single list. NumPy arrays has to have either only integers or only floats, things like that. Moving on. So rounding up and rounding down, usually you just want to find you want to round it to a certain number of decimal places. So if we run this, you're going to round it up to 2 decimal places. But if you want to round it to say 100, to the nearest 100, you would just do a -2. So two decimal places behind the decimal place itself. So it rounds it up to the nearest 100. You can use this when you want to perhaps bin your data before plotting it or something like that. Moving on to distributions, I will not be going into what each distribution is. That will be covered up in the next talk, which is on 31st, I believe. But normal distribution, as expected, it basically has a mean and a standard deviation. And if you feed this into numpy.random, you can get you can generate random values between with a mean of 0 and a standard deviation of 1. You obviously need to specify the number of elements which need to be generated. So X is a NumPy array. In this case, I have generated 100,000 elements. This is just so that I can plot it and you can see the distribution. But in general, you can just generate 10 and it is still a normal distribution, but it is not clearly visible in a plot. The plotting functions here is NumPy has this, Matplotlib has this function called histogram, which automatically calculates, which automatically generates a distribution plot. I'll get into it a bit below, but I just want you to keep this in mind that histogram just requires a single input. It doesn't need a X value and a Y value. It automatically calculates the frequency of the element occurring, of course, in bins. So we specify the number of bins.
What's a bin?
Okay, a bin is basically, so suppose you have a single value of say 0.001, all right? And then you have another value 0.002. But if you check the frequency of each element, the values of the number of elements between 0 and 1, if you calculate the number of possible numbers, it is infinite, right? So the probability of a number repeating is so small that you're not going to see a normal distribution. So you want to check how many times a number is repeated, which is in between say 0.1 and 0.2. So if I set this to say 10 and plot it, so let me just see. Okay, yeah. So if you want, this basically says that this is not a great example, but anyway. So between say 0 and wherever this ends, say 1, between 0 and 1, the number of numbers generated was around 27,000. So that is a bin. It is a range between which the frequency is calculated. Is that clear? I believe it was.
Yeah, it's clear.
Yeah. Any other questions before I move on to discrete distributions?
Over here in the where you're using the subplot line, I see that you've typed up fig comma ax equal to. So fig is a code or like is just
So this this function in general returns two values, but fig is in general not used by any of us. I believe it contains the total number of figures being plotted, but again, don't quote me on that. In general, we don't use this variable, but we do need to specify it because it is it is a tuple which is returned, and we want to make sure that ax gets the first one.
so if I delete the fig, then would the program run by itself? I mean, would the program run or not?
Something like this, or do you mean
Yep.
like this?
Yeah, like this.
You would probably have to do something like this to get it to run. If you don't do this, it's not going to run. Do you understand?
Okay. Yeah.
This is, everything is a function. All right. So this returns two values. One is called fig and one is called axis. Axis is the one in which you need to provide all the values, all the plotting data. If to put it in a simple way. So fig doesn't require you to do anything. It is not used at all. But since it is returned first, you need to put this here. Do you understand?
Yeah, I get that.
All right. So this is this is because it returns a tuple. All right. In general, you would just copy this line and you would repeatedly use this. I do want to specify this is not mandatory. This is used if you are using a small screen. It generally tends to sometimes cram in values together. So just putting this, make sure that the values are not, overlapping over one another. This by no means is mandatory. If you are using a desktop monitor, it doesn't make a lot of difference. Okay. This was let me just put this at, where did that go? We just leave this there, and I just want to show some statistical calculations using Numpy. So since we have a normal distribution, we expect the mean to be 0, standard deviation of 1. So if you calculate the sample mean from this, you get a mean is very, very close to 0. The standard deviation is very, very close to 1. Variance is nothing but the square of the standard deviation, or in general, we define standard deviation as the square root of variance, which is obviously, again, since it is lower than 1 here, the sample standard deviation is lower than 1. When you square it, it is going to be lower than the standard deviation itself. And then you have maximum and minimum. The functions are pretty simple. It is the np.mean, np.std for standard deviation, var for variance, amin is for minimum values. You could do something like nen min as well, I think is the function. So nen min and a min. So the meaning of a is all. So it checks through all the values in the array of x, in the x array. If you wanted to ignore all the NANs present in your data, which is probably the case if you're using some real world data, sometimes people don't fill in some data and it's missing. When you convert it into a NumPy array, it appears as a NAN. If you want to ignore those values, you do NAN mean, and it basically ignores everything, all the NANs in the distribution. Similarly, max also, you have NAN max, and it works the same. Since in this case we don't have any NANs, it's going to return the same value. Is that clear? Any questions? Okay, so normal distribution is a continuous distribution. And the reason I'm just showing normal distribution and I'm not going into gamma distribution or beta distribution or the chi-square distribution is because in practice, you never usually come up with a place where you want to showcase a chi-square distribution. It's very rare, and that's the reason I'm not showcasing it here. There is one other distribution which I probably have not written into this script. Anyway, let me just, did I though? Binomial distribution. Okay, I do have it here. Anyway. So a binomial distribution is a discrete distribution. This basically says, I'm going to do an experiment for 10 times, which is the number of runs. Okay. The experiment is I'm going to flip a coin 10 times and I want to see how many times I get heads. So in the first time, the probability of getting heads is 0.5. So I have specified that here. First time when I flipped it for 10 times, I got 6 heads, and the second time 3 heads. So this is calculated by the binomial distribution. Again, I will go into this in the next talk as to how what a binomial distribution actually is. But if anyone didn't get an idea of what binomial distribution is, please do ask. Anyone? Okay, so a binomial, this is the general idea of a binomial distribution. I'm just going to, here I just put in 10 and 10. I just want to showcase how a binomial distribution does when you increase the number of bins and increase the number of runs and everything, increase the number of trials. Does this graph look similar to the normal distribution? If it does, you are right. It is because a binomial distribution, if you tend n to infinity, appears to be very similar to a normal distribution. Of course, the mean would be skewed depending on the probability. Here, the probability is 0.5, which is why you have a perfect normal distribution. Depending on the probability, if you change the probability to say 0.7, it is going to have a skewed distribution. Okay. Moving on. Again, I just want to showcase the calculations on this distribution. All values are integers. So here you would see that the mean, even though all are integers, is going to return a float value. This again would have not been the case if you were using Python 2. As you remember from the beginning, it would have returned a value which is an integer. Similarly, the standard deviation, variance, calculating the mean is as expected because 0.5 and you're running it for 100 runs. So the mean is 50. The standard deviation and variance of of this distribution, the binomial distribution, is it has its own formulas, and I will get into it in the next talk. Finally, the uniform distribution. This distribution is it is not a distribution per se. All it does is generate values between a minimum and maximum value with the same probability. So this is generally used if you want a random number between 0 and 1. It is better to use a uniform distribution. Depending on your use case, you would either use uniform or you would use a normal distribution. But this is another function in Numpy. So np.uniform. Any questions on Numpy so far? Anyone? Give me something, some sort of feedback, just to know that you guys are understanding what I'm trying to say. Okay, great. I do see some chat messages. So all right. Moving on to Pandas. Pandas is it is a very large package. It has a lot of functionality built in. The main reason Pandas is used is for its data structures, which is the data frame and series, but it also provides a lot of tools for data analysis. So if you want to calculate correlations or your covariance correlations, if you want to plot the correlation and covariance in a heat plot, for example, all that can be done using just Pandas and even without touching Matplotlib. But here, I just want to make sure you guys know what series and data frames are. Series is basically an array. So in NumPy, it was called NumPy array. In Python, it was called list. In Pandas, it is called as series. Data frame is basically, if you load in a CSV or an Excel file into Python and you want to call it something, it is going to be called as a data frame. It is basically a table with all the data in it. It can be compared to a two-dimensional matrix, but it doesn't. It is, and in fact, it is pretty similar to a NumPy two-dimensional matrix. But instead of being called by its argument, as in the location, you can call it by its index and column name, which can be named explicitly, which is what makes data frames, attractive for data scientists. I will be showcasing how data frames work ahead. And Matplotlib. The reason I'm introducing both of these together is because Pandas can also be used for plotting, and I want to showcase the difference between Pandas and Matplotlib's plotting. So Matplotlib is, again, as I said, it is just a plotting tool. It is a core plotting tool in Python. So even though Pandas has plotting functions, it makes use of Matplotlib's functions to generate the plots. Pandas works as some kind of a wrapper over Matplotlib. And the data set which I want to showcase is the iris data set. Has anyone of you ever used iris dataset before, or do you guys know what it is? It is a very popular dataset, which is why I'm asking. Okay, cool. So you guys know what it is. A very small dataset. Okay, I believe someone has not used the iris dataset before. So let me just explain it quickly. So it has 150 records, which is basically, let me just run through it. Let me just run this, and let me just show you. So it has 4 columns, which is sepal length, sepal width, petal length, and petal width, which is basically the iris is a type of flower. And there are 3 types of iris flowers, which is basically iris centosa, iris vesicolor, I believe, and however you pronounce this. I'm not great at pronunciations. So they all have unique sepal lengths and sepal widths, and this data has been recorded into a data set. It is a small data set with just 150 records, but the reason it is very popular is because it can be used, it is a balanced data set, and it can be used to evaluate any kind of classification model, which is required in case of data mining or in case of machine learning. So I've just sampled 10 rows from the 150 elements, 150 rows in the data set. Here I just, this part I do not expect you to understand. This is because this is basically using something from scikit-learn. I just wanted to load in the data set and then explain how things work. So just assume that you have a data set data frame called iris with this data in it. All right. Here I just want to showcase some functionality built into a pandas data frame. Here, so the column names can be got with by using iris.columns, which is the data frame.columns. It returns an array with the column names, which is serial number, sepal and sepal width, petal length, and type. Type 0, type 1, and type 2 is basically this. I have also put in the shape of the data frame, which is 150 rows, 6 columns, because of 1, 2, 3, 4, 5, and 6. And size of 900 is basically 150 into 6, which gives 900. Number of samples available for each type is basically counting the unique values in the type column. So as you can see here, we use iris type dot value counts, and it says 1 has 50, 0 has 50, 1 has 50, and 2 has 50. So this is why I said the data type is the data set is balanced. Iris.describe. So the data frame has an inbuilt function called describe, which gives you a lot of the statistics for each column directly. So count basically says how many elements are present in the row, in the column, mean of the column, standard deviation of the column, so on. Quartiles, so 25th percentile, the 25th percentile, 50th percentile, 75th percentile, and the maximum value. So the 50th percentile is basically the mode. So this is what I meant to say. Here, I wanted to plot the data for the number of types of the data set, the column type. So here, as you can see, I'm using Matplotlib in this case, and and here p.data np.histogram. Basically, what this does is it calculates this. So it returns if I just print out this data here. It returns the values for 0, 1, and 2, how the frequency of its occurrence. All right. And this is what I'm plotting here. The labels array contains the labels for each one again. I do want to make you guys take a note here that when you specify bins for np.histogram, np.histogram is what is calculating the frequency. You specify, even though that there is just 0, 1, and 2, I am specifying 0, 1, 2, and 3. The reason is it is bins, and bins calculates the frequency in a range. And here the range is not a single number. So the bins in this case is going to be 0, 1, between 0 and 1, and then 1 and 2, and then 2 and 3. So for this reason, you have to specify one more than the original. It includes, when it calculates the bins, it includes 0 and doesn't include 1 in the first bin. Second bin, again, it includes 1 but does not include 2. But in the final bin, it includes 2 and it includes 3 as well. This is using Matplotlib. As you can see, there are some functions which some arguments in the function for for the pie chart, which don't make a lot of sense. Labels is basically labels. Auto PCT basically says that you want to make sure of how the data is formatted inside. So I just wanted to have a single decimal place on the inside. Start angle of 90 says that you start at 90 degrees here. You can rotate it as much as you want. So if I just say change this to 45, it is going to rotate by 45 degrees. Any questions? Anyone?
I just had a question actually on Pandas versus Numpy. Is there a like a computational efficiency difference between storing data in a Numpy array versus a Pandas data frame?
Computationally, Pandas data frame is going to take up a bit more time if you want to calculate something. The optimization of calculations is something which is very important. But if you are just a data scientist and you don't really care about time, but you just want results and you want to conveniently calculate something, you would probably be using Pandas.
Okay.
All right.
Thank you.
So Python in its core is a single threaded language. When I say Python, I'm talking of C Python. So C Python by default uses just a single thread. So if you want to calculate multiple processes, if you want to perform multiple calculations on multiple threads, it is not very easily possible. I will be talking about this when I do a lot of large calculations. So in the next talk, when we talk about statistical methods, you will be calculating all these, you'll be doing large calculations, and I want to show you how you can save time. I will be showing how to do calculations using multi-cores and even using your GPU. If you do have a GPU, how do you make Python use the GPU to calculate, to do vector calculations quickly, and it saves a lot of time.
Cool. Thanks.
Cool. Any other questions? All right. So here I just wanted to show how the Pandas data frame by itself has an inbuilt functionality to plot. As you can see, I just set up the data frame here to calculate this is basically what I did here. If I just run this and I can show you that the new data frame is created 0, 1, 2 and 50, 50, 50. And if I just say dot plot and specify a few arguments similar to the arguments here, it generates a plot. But what I do want to show here is, as I said, Pandas is just a wrapper for Matplotlib. So if you do plot, you need to do a plot.show at the end to make sure that the plot is shown. Of course, in a Jupyter notebook like this, it's going to showcase it anyway, but it is going to give this ugly output as well. So if you put this plot.show, it knows that it has to plot it out. All right. I believe we are squeezing on time. So we have very less time left. So let me just go through this quickly. Scatter plots are another type of plots which you can get out of Matplotlib. Here I'm just plotting sepal length and sepal width here, and I just want to make sure I've color coded it based on the type. So I have not put in a label here. Let me just see. Just This is the way. Okay. I'll need to take a look as to how the legends are plotted again. Oh, wait, I can do this. No. Anyway, I will update the code to show the legend on GitHub. Anyway, so the colors basically showcase that the type, and as you can see, if we take a look at sepal width and sepal length, you can't see a distinct separation between the three types. However, if you take a look at petal length versus petal width, you can see that they are distinct, and these are the kinds of inferences which you need to make from plots. Using this plot, you can probably say that using sepal width and sepal length to classify the different types of iris flowers is a bad idea, but using petal width and petal length is a good idea. Some other plots which are possible using Matplotlib is the line plot. It is the most basic of plots. You just use plot and you just give the x and y values. ax.set basically sets all the values. You can also do, instead of this, you can just do ax.x label and then set the values, but you can also use ax.set directly, and you can specify all the arguments inside. ax.grid is what generates the grid here. Fig.fig save, again, the time when you would use fig is to save the figure generated into a file. All right. So if I do this and run it, if you take a look here, there was, where is it? Doc one. So there's a test.png, which basically has the image saved now. Moving on here, this is just something for fun. I will not be explaining as to how this is being generated. It is a pretty complex function which is being used here. But anyway, so you can also produce three-dimensional plots. Other than Matplotlib, you have some functions, some packages such as Plotly and Seaborn. Seaborn is again very popular among data scientists because it also has, like Pandas, it also has the ability to calculate, statistical functions. So if I run this on the iris dataset, again, you can see the petal length has pretty good overlap here, but it is distinguishing the first zero type very well. But as you go into sepal width, it is overlapping for all types, and so sepal, we can, from looking at this data, you can say that sepal width is not a good. But I do want to say that this is Seaborn, and I'm not going to be explaining as to how Seaborn is used here. Data frames can be loaded, can be used to can be read from CSV files. This is something which I needed to show earlier, but I guess I just missed it. So Pandas has a read CSV function which can let you read a file from your computer and load it into the data frame. So if I I have a CSV file called mismanaged waste global total.csv, and it has these values, and now it has been loaded into a data frame here. So if I want to do if I want to plot data here based on the country, I'm using Plotly here. So Plotly can be used to generate maps, and so if you hover over the map and it gives you the value of the mismanaged waste, and you can also use a heat map to showcase how severe it is or something like that. So Plotly can be used to generate maps is the point which I wanted to showcase here. I just loaded in another data frame here, and I just wanted to showcase that You can also use Plotly to generate moving graphs. So over time, how does data change? So things like that can be done using Plotly. All these, again, as I want to specify that they are all wrappers for Matplotlib, and all this can be done using Matplotlib, but is more difficult to do because it requires a lot of programming. Okay, so that's it for the programming part, but I do want to specify the use case of Python Matplotlib over R or Tableau. So R and Tableau is much, much better for plotting data than Matplotlib for obvious reasons. R has a very mature ggplot library, which can generate plots easily and which look better. Python, you can make plots in Matplotlib look like ggplot using this command at the beginning. But the thing is, it doesn't give you the functionality. It just gives you the look of the final plot. So R and if you want to, if you're working in data visualization and want to present a few plots to your boss, you would probably be better off using R or Tableau. But if you're a data scientist who wants to visualize the distribution in real time, or you want to you want to just see how your model is performing, for example, you would probably use Matplotlib because your model is more likely than not, it is going to be using, Python, because you would have built the model using Python and you want to see it in real time. So shifting between different programming languages is difficult. So you would use Matplotlib. That is the reason Matplotlib exists. Yes, you can generate extremely advanced plots, but it is difficult to generate it using Matplotlib. All right, guys, I guess we are 6 minutes over time. So if any questions, that is it from my end. I will be talking more about this in the next talk as well, because we will be doing statistical analysis. But if you guys have any questions, please let me know.
Thank you, Ashwin. Thank you very much. And
Yeah, thanks so much.
Thank you so much, Ashwin. Thank you so much for replacing Zahil too for the next few weeks.
Excuse me.
Yes.
May I know what's the main topic for the next session?
I'm sorry?
Can you just tell us what's the main topic for the next class?
The topic is going to be statistics. So I will be talking in detail about distributions and statistical analysis. I will also be talking about how to optimize code so that if you have a large number of calculations, how do you perform large calculations in less time?
Okay, thank you.
Sure thing.